As a student, frustrated by the limitations of conventional mathematics, he invented an entirely new form, the calculus, but then told no one about it for 27 years. In like manner, he did work in optics that transformed our understanding of light and laid the foundation for the science of spectroscopy, and again chose not to share the results for 3 decades. In 1684, Dr. Halley came to visit at Cambridge, and after they had some time together, the doctor asked him what he thought the curve would be that would be described by the planets, supposing the force of attraction toward the sun to be reciprocal to the square of their distance from it. This was a reference to a piece of mathematics known as the inverse square law, which Halley was convinced lay at the heart of the explanation, though he wasn't sure exactly how. Sir Isaac replied immediately that it would be an ellipse. The doctor, struck with joy and amazement, asked him how he knew it. "Why," saith he, "I have calculated it." Whereupon Dr. Halley asked him for his calculation without further delay. Sir Isaac looked among his papers, but could not find it. This was astounding, like someone saying he had found a cure for cancer, but couldn't remember where he had put the formula. Pressed by Halley, Newton agreed to redo the calculations and produce a paper. He did as promised, but then did much more. He retired for 2 years of intensive reflection and scribbling, and at length produced his masterwork, the Philosophiae Naturalis Principia Mathematica, or Mathematical Principles of Natural Philosophy, better known as the Principia. Once in a great while, a few times in history, a human mind produces an observation so acute and unexpected that people can't quite decide which is the more amazing, the fact or the thinking of it. Principia was one of those moments. It made Newton instantly famous. For the rest of his life he would be draped with plaudits and honours, becoming, among much else, the first person in Britain knighted for scientific achievement. Even the great German mathematician Gottfried von Leibniz, with whom Newton had a long, bitter fight over priority for the invention of the calculus, thought his contributions to mathematics equal to all the accumulated work that had preceded him. "Nearer the gods no mortal may approach," wrote Halley, in a sentiment that was endlessly echoed by his contemporaries and by many others since.